Here we are in Math 3, Lesson 4, Practice 1.4.3, Estimating Sample Means. So here we're going to use this formula for the sample standard error of the mean, okay, for these following situations. So S is our standard deviation and N is the sample size. So let's take a look at number 1. A survey of 18 students found that they spent $300 per month for car-related expenses with a standard deviation of $99. So to find the standard error of the mean, we take S, standard deviation, which was 99, divided by the square root of N, which is our sample size, which was 18 students. Okay, so most likely we're just going to type that in a calculator, see what we come up with. So we take that, we type it into our calculator, we end up with 23.3345. Okay, so that's rounded to the nearest hundredth, 33. Look behind, it's 4. So 23.33 would be our standard error of the mean. So remember, when we're looking at the standard error of the mean, it tells us what the possibilities for the mean of the whole population. So since we only dealt with these 18 students, what if we were to do this for all students, that whole population, not just the sample, the whole population. So we take that 23.3 and we add it to 99, and we also subtract it from 99. Okay, you don't have to do this part, but I'm just reminding you what this whole thing deals with. So add it together. 3 and 9 make 12. So 122.33. And then if we subtract it, right, it'd be what, 0.77? Or no, 0.67. And then 6 and 7. So that means that our population mean could be anywhere from 76.67 to 122.33. Okay, so for our whole population, that's quite a range, but our mean is going to fit somewhere within that. That's what the SEM, the standard error of the mean, helps us figure out. Okay, so just keep that in mind. We're really dealing a lot with just finding it, but just keep that in mind that that's what the reason is behind it. Okay? Alright, let's take a look at number 2 now. A clinical trial found that blood pressure dropped an average of 12 points with a standard deviation of 7 points for 49 participants who regularly meditated for 15 minutes per day. So we need the S, which is our standard deviation, which they told us was 7 points. And our N was the number of people, so 49. So for our standard error of the mean, we go 7 divided by the square root of 49. Now, we know what the square root of 49 is, right? 7 times 7. So I can simplify that without a calculator. 7 over 7 gives us 1. Round to the nearest hundredth, you just add the 2 zeros. So once again, that's 1. So for the mean for everybody else would be, somewhere around plus or minus 12. And actually, I think I told you wrong on number 1, right? I think the 300, we'd add the 23 to that, not to the standard deviation, and we'd subtract it from that. Okay, so my idea was right, but with the wrong numbers. Okay, so that says plus or minus 1 means from 11 to 13 points is going to be the mean for our population, somewhere around those numbers. Okay? So number 3. A group of 5 students who did poorly on a college entrance exam test took a test preparation course offered on Saturdays. After finishing the course and retaking the test, their scores increased by an average of 100 points with a standard deviation of 16. So we have 5 students, 16 points. So it'd be 16 over the square root of 5. So then we type that into a calculator to get this answer. So we get 7.1554, rounded nearest hundredth. Look behind the 5, it's a 5, so 7.16. Okay, so their scores increased by 7.16. Okay. Alright. So number 4. A randomly selected sample of 100 people was asked to count the number of contacts in their phone. The average number of contacts was 250 with a standard deviation of 100 contacts. Ooh, that's quite the range, huh? So, we go for our standard error of the mean, take our standard deviation, 100, divide by the total number of people, which was also 100. Okay, so square root of 100 gives us 10. 100 divided by 10 is also 10. So our standard error of the mean was 10 contacts. Okay, number 5. Arena workers polled the first 90 people in line for a concert and asked each person how much they had paid for their ticket. So n would equal 90. Okay, what's our standard deviation? The average was 125 with a standard deviation of 57. Okay, so we would go for our standard error of the mean. We would go 57 divided by the square root of 90. We type that into our calculator and we get this for our answer. We get 6.008, round to the nearest hundredth, so that would bump it up to 6.01. And that would be money, right? Okay, let's keep on going. A sample of 3,000 middle-aged men, so there's our n, found their average weight was 250 with the standard deviation being 12 pounds. So 12 is our standard deviation. We just put it into our formula. So 12 divided by square root of 3,000, and that's going to give us the number we need. So we get, when we put in our calculator, 0.219, round to the nearest hundredth, that bump it up to 0.22. Okay, a school district's transportation director reviewed the average distance from a sample of students' homes to their schools. She found that in the 125 student sample, there's our n, the average distance was 5.6 miles with a standard deviation of 1.85. So for our SEM, we go 1.85 divided by the square root of 125. Okay, type that one into your calculator and we get our answer, which looks like this. We get 0.1654. So we round that to the nearest hundredth. It's a 5, so that bumps it up to 1.7. Okay, so this stuff really isn't too bad, right? We're just essentially plugging things into that formula and using it, solving it. A baseball team with 25 players has an overall batting average of .240 with a standard deviation of 0.025. So S is 0.025 and N is 25. So we get 0.025 divided by the square root of 25, which is 5, right? Square root of 25 is 5. So we type that into our calculator to get our answer. And we get 0.005, which they want us to round to the nearest hundredth, so we bump that up to 0.01 because of the 5. Alright, an analysis of 41 items on a cafe's menu found that the menu items had an average of 450 calories, with a standard deviation of 223, all 41. So N is 41, S is 223. So our standard error of the mean is 223 divided by the square root of 41. You type that into your calculator and we get our answer. So we get 34.8267, round to the nearest hundredth. That would bump it up to 34.83. Okay, the last one. A music reporter studied the average length of CDs issued by a particular record label, can't speak apparently. On 500 CDs, the average length was 33 minutes with a standard deviation of 4. So standard deviation of 4. Total number was 500. So for our last SEM today, we go 4 divided by the square root of 500. We'll type that into our calculator and get this for our answer. 0.178885, and then it keeps going, so nearest hundredth, that'll bump us up to 0.18. So there we go. That's all there is for the SEM. To find it, and just remember that you use those numbers to add or subtract to the average, and I'll tell you what the whole population, because we just dealt with the sample, so we're once again still applying this all to the whole population. But there we go, guys. That should be everything you needed.